Okay, we're going to talk about negative exponents, which is also known as integer exponents. Let me just change this color. Integer exponents, okay? So what we're going to be looking at is the rule of when the exponent is a negative and what that means, okay? It can be really hard to fathom what this means to be a negative exponent. So what we tend to do is we tend to rearrange a question so that we have a positive exponent. So in this case, if our base is the letter x, it could be any number, it could be like 5, right, to the power of -2. Well, what we can do is we can take that number and make it the denominator of a fraction. Okay, so it becomes 1 over x to the power of 2. Okay, and really what's happening there is this whole thing is really put to the power of 2, because what we did is we made this whole integer here, or this base, a fraction. We put it over 1, and then to invert it, we kind of did this. And what we mean by that is this is a much better example of that, where we actually look at a fraction. We have a over b to the power of -3. Well, if we want that to be a positive exponent, we just invert what we originally had. Okay, so let's go through a couple of examples. I'll start with a simple one. Let's say we have example 1, 6 to the power of -3. Okay, let's say I wanted to make that a positive exponent. What would I do in this case? Do you know off the top of your head? Think of what we did up here. Okay, first let's try to make this, let's try to refer everything, because I think it'll be easiest, to this example. In other words, we're going to make, anytime we have an exponent that's negative, we're going to make the base a fraction. Okay, so every single time we need to make a base a fraction. So how would I make 6 a fraction?
6 over 1.
6 over 1. Okay, and we can always write it like this, as if this is the power of that. Okay, so now I want to make the exponent positive. What do I do in this case?
You reverse it.
Okay, so what will it read, the base?
1 over 6.
1 over 6 to the power of?
3.
3, that's it. We now have a positive exponent. Okay, so whenever we're going to do this, let's always make it a fraction. It'll make things easier for us. Okay, so let's go into another one where we have to do a little simplification. Let's say we have something like 2 to the power of 4 times 2 to the power of 2 divided by 2 to the power of -6. Now, in this one here, it'll be easiest if we actually just go through our exponent laws and at the very end we fix this. Okay? So, according to BEDMAS, we have multiplication and we have division. Okay? So we kind of just go from left to right. Because we have to multiply these two exponents, how do we simplify these two?
You have to add the powers.
That's right. We add these two powers here. So I'm going to rewrite this. It'll now say 2 to the power of what?
6.
6, that's right. We add those two together, we get 6. Now it says divided by 2 to the -6. I'm going to rewrite this. It could also look like this. 2 to the power of 6 over 2 to the power of -6. That fraction essentially means divide, right? So what will we be doing with these two integers here if it's division?
Subtracting.
Yeah, we subtract. So I'm going to rewrite it again. In this case, it says 2, okay? And I'm going to take those exponents, so I'm going to highlight what I've done here. And this becomes 6 subtract -6, okay? So this is not quite the same as just subtracting 6 from 6. These two exponents kind of make a positive, right? And in this case, we end up with 2 to the power of, and you can rewrite this like 6 plus 6, okay? And I guess I should have a little equal sign out here on all of these. But what will our final answer be in this case then?
2 plus 12. Or 2 to the power of 12.
2 to the power of 12. And I guess I should have chosen a question where we get a negative integer. It would have been much nicer in this case. Let's see if I can, I'll make a quick one up. Okay, one where we have to use all 3. Okay, so we're using a whole bunch of rules here. Let's say we have 10 to the power of 5, okay, to the power of 3, divided by 10 to the power of 20. Okay, and we need to simplify this. So let's deal with what's on top first. If we have a power of a power, do you know what operation we use between these exponents?
You have to multiply.
That's right, we have to multiply those two. So what is our 5 by 3, or 3 5s, going to equate to? Let's see if we can do it. You have a calculator? Okay. So I'll rewrite it so it looks like this.
125.
5 by 3. Try that
15.
again. Yeah, that's right, 15. So we have 10 to the power of 15, okay, divided by 10 to the power of 20. So what do we do with those two exponents?
Subtract it.
That's right, we subtract the two. So we subtract them, it'll be 10 to the power of 15 minus 20. What will that give us? Use that integer there.
-5.
Yeah. So 10 to the power of -5. Now we want to make this a positive exponent. So what's the first step here?
We have to put a base to it.
Yeah, let's put a base. We want to make that base a fraction. So how do we do that?
10 over 1.
Great. Okay. So now let's make this positive. What do we do here?
We reverse it.
All right. What will it read?
1 over 10.
1 over 10 to the power of
5.
That's it. And you're done. A lot of times they'll write it like this, 1 over 10 to the 5. And the reason they'll do that, okay, so we'll quickly explain this, is because think of it like this. This is to the power of 1 and this is to the power of 1. So if you remember the power over power rule, we did 5 times 3 when we had power over power, right? So if we go down, I guess I'll go down. If we go down here, think of this like a power of a power. This becomes 5 times 1 and 5 times 1. So really this becomes 1 to the power of 5 and 10 to the power of 5. But 1 to the power of 5 is 1 by 1 by 1 by 1 by 1, which is still just
5.
1,
Oh,
right?
Yeah.
And then on the bottom we have 10 to the power of 5. Okay, so that's the idea behind our exponents there.